Hello everybody, Ron aka Daddy Geek, back here with another Disney Infinity 2.0 toy box tutorial. And in this tutorial we're going to take a look at those blocks that you see right behind Donald there. And those aren't regular building blocks, those are color changing blocks. And as the name implies, the blocks can can change color when a signal is sent to them. When you have to use some type of logic connection, whether it be a trigger area switch or what have you, some type of action has to change the color of the blocks. Now, they share a similarity with the color changing plates in that they change color and you can use the color changing to trigger off other logic toys or say open a door or a chest or what have you. But there's a major difference where when you use a color changing plate, as you may have seen in the logic gate and plate tutorial, you only really need one logic gate per color changing plate. The exact opposite is true for color changing blocks. The blocks themselves change color, and in order to control the input and the output and the logic coming into and leaving the blocks, you're going to need basically one logic gate per color that you want to use. So you'll need to use several logic gates, and you'll see an example of that behind me here as we get moving on in this tutorial. But I just kind of want to give you a heads up. This is one reason why I think these color changing blocks can pose a little bit more problem to players than say the color changing plates, because they're a little bit more, I don't want to say backwards, but that's kind of a good term to use. Like they're a little bit, it's almost like a reverse of the color changing plates. So anyway, let's go over here and let's start with a basic example of the color changing block. As you can see here, it looks like a regular building block. By default it's dark gray, just as you see here, and that's pretty much it. It's a block. It's exactly the same size as your basic building block that you can find underneath of your editor. Now here's the difference. We're going to highlight this. We're going to go into properties. Now under properties you have one selection, default color, and as you can see by default the default color is dark gray. Now if we go in here you'll see that there's several colors: black, blue, gray, dark gray, excuse me, green, gray, light blue, orange, pink, purple, red, white, yellow, all the colors of the rainbow, and a few extras. So you can change it to whatever you want. So for example, we'll make the default color green, and as you can see, the block turned green. Now that is all you can do for properties. You can just set the default color of the block, and again, if you just place it down into your world directly from the editor, it's going to be dark gray. Now we bring it up again with the wand, you'll see that there's a new logic connection. Now see, this is where you'll need to use logic gates, because when we click new logic connection, all we see is one option. It says color changed. So the only time that this block will send out a logic signal to another toy is when it changes color. Now that's not color specific though. So if, say for example, you wanted a logic signal to be relayed through this block to leave the block and go to another toy like that chest next to us, only when the block turned green. You can't do that without a logic gate, because the block does not distinguish in its logic. It does not distinguish between colors. It just, whenever it changes color, regardless of whether it's red, blue, green, orange, whatever, it's just whenever it changes color, that's going to send out the logic signal. So you need a logic gate in order to change that. And I'll show you a perfect example of what I mean. So for example, we're going to do new logic connection, stepped on, player, any, to our block, and we're going to, you have options of restore, which restore means it will go back to its default color. Red, green, blue, yellow, orange, purple, pink, light blue, black, white, gray, dark gray, random. So for example, right now I'm going to just put random. So when we step on the switch, the block will just pick a random color and change color. So here we go, we'll step on it. There's dark gray, there's black, yellow, went back to green, went to green again, yellow, or actually I think that's technically orange, blue, and then another gray and a pink. Now, if we go ahead and continue our logic connection, we do new logic connection, color changed, we go to this, we'll say spawn loop, you'll see that it doesn't matter. And I'll put one more switch down just so we can reset the chest. Let's grab another switch, put it down, spin it around, And now we'll connect this to the chest and we'll use it as a reset button. New logic connection, stepped on, player, any, and we'll go to the chest and we'll hit reset chest. Alright, so when we step on this, no matter what color it changes to, it's going to open that chest. So we'll step on it, and it spawned our cake, and it stayed the color pink. Now we'll reset the chest, step on it again, black. As you can see, it will, no matter what color we pick, it's going to continuously spawn the loot out of the chest because it's not color specific. It's just the black has to change color for the logic to happen. Okay? So now we're going to go over here and I'm going to show you how we're going to use logic gates to control which color the block changes to and also which color the logic connection goes from the block to another toy. I already have the one over here on the right set up to save us some time, so we're just going to use the one on the left here. So the first thing we're going to do is we need to make our connection from the switch itself to one of our logic gates. So here's what we're going to do. Going to highlight our switch. We're going to do new logic connection, stepped on, player, any. We're going to go to our first logic gate here, and we're going to say input. If you remember with logic gates, you can send an input signal to a logic gate, and then there's an output signal that goes from the logic gate. So what we're going to do is we're just going to say if this gate is open. Remember, logic gates are just like doors. They can open or close and block signals going through. We're going to do new logic connection, output, and we're going to go to our color changing block here, and we're going to tell it to change to, we'll say blue. So now when we step on this pad, as you can see, it turned blue. Worked exactly as advertised. Now, we keep stepping on this, all it's ever going to do is change blue. It's never going to do anything else. So now we can change it though, so we can cycle through the colors. So here's how we do that. Bring up our logic gate again. Now, just to know, you're never, at this point, we're not going to be making any more connections from that switch. We only needed to make the one initial connection. After that, everything else is done through the logic gate. So we're going to do a new logic connection. If this gate is open and the output goes to the color change block and changes color, we need to also send an output to the next logic gate to open that one, so we can have it be the so we can allow the button to change to the next color. So we're going to go output to this logic gate, and we're going to tell it to open. Now, if this logic gate is open, we need to close the other logic gates. Otherwise, the signals will get confused, and if all the logic gates are open, it won't work. So we're going to do. Let's see, what did I do? Did I already do that? No, I didn't. Yes, I did. I lost track that quick. How I was doing that. Oh, that was output. Okay, new logic connection. If this gate is open, then these other gates have to be closed. So we're going to close this gate. We're going to do the same connection from here to the other gate. So if this gate is open, these two have to be closed. Because these other two logic gates, this one and this one, are going to control different colors. So if we want the button to cycle through the different colors of the block, we need to close the other gates. Alright, so now if this gate is closed and we want the next color to fire off, we need to send an input. Now, if you remember from our other tutorial, when an input signal hits a closed gate, it bounces off that gate, the door's closed, the signal bounces off and goes to the next wherever we tell it to go, and that signal is called an input block. So we're going to do new logic connection, input blocked. So if the input from the switch hits that gate and it's blocked, it's going to bounce to the next logic gate. We're going to go to this logic gate and we're going to say input. So now with this logic gate, when it's open, the signal passes through, changes the color of the block to blue. And it also, in turn, will open the next logic gate so we can continue on down the line of colors. Now, if this logic gate is open, the other two have to be closed. If this logic gate is closed and the signal hits it, it's going to bounce to the next logic gate the logic gate that we connected to it, and the signal is going to go then see if that logic gate is closed or not, and if it's open, it's going to pass through. So that's it for that gate. So now we got to do the next one. So what we're going to do is new logic connection, and again, we're going to start with the output. So we have an output, and we're going to go to the color changing block, and we're going to pick, we'll say yellow. So now that one, so now if the first logic gate is closed, this one's going to be yellow. So now in order to continue that, we're going to, once again, if this logic gate is open, the other ones have to be closed. So open, this logic gate is open, this one has to be closed. If this logic gate is open, this one has to be closed. And now we are also going to send a new logic connection, and we're going to do an output, and it has to go to this logic gate and open it up. So it prepares basically you're preparing the game, you're preparing the switch and the block for the next color. And then we need to send one more signal. After that, we'll need to do new logic connection, input blocked. What happens if this logic gate is blocked and it can't turn the block to the color yellow? It's going to bounce to the next logic gate, and the input signal is going to travel to that gate, see if that gate's closed. If it's open, it'll go through and change the color to whatever we desire. So we'll do input. Now we have one final one to do here, because we're just going to cycle through 3 colors. Alright, now for this one, we want the correct color to be red. So we're going to do output to our block, and we're going to say red. We're also going to do new logic connection. Output. Since this is the correct color, we're going to light up this torch. Maybe. There we go. We're going to light up this torch. And we're going to tell it turn on. Now we also need to send an output signal from here to the very first gate again to open that one up. We're basically just creating a circuit, creating a cycle here. And once again, we're going to do the same exact things we did with the other 2 logic gates. New logic connection. We're going to tell it if this gate is open, these ones have to be closed. Close. New logic connection, open, and we're going to close the last one. Now also, with this one, we're also going to do new logic connection, and we're going to do, again, input blocked. If this logic gate is blocked, it's going to go back to the first logic gate and send that signal, and we're just creating a continuous cycle. And you know what, before we light up that torch, let me do one thing so I can show you how this works. We're going to delete that link to the torch for right now, because we have a grand finale planned once all this works. So the correct color is going to be red here. This one's already set up that the correct color should be green. So let's just see if this cycles through the things. So yellow, red, blue, yellow, red, and back to blue. And again, the reason why that worked is when this first logic gate is open, one of them is always going to be open. So when, for example, when this first one is open, we stepped on the switch, since the gate was open, the signal passed through and turned the block blue. But once that happened, the output signal then opened up this gate, and since we told this gate, when this one's open, the other ones have to be closed, it closes this one. When we step on the switch, the signal goes to this first gate. Since it's now closed, bounces off, hits the second gate, and since the second gate's open, it changes it to yellow. I believe we set it to. Now, when that signal hits this gate, though, again, it will open up this gate, but then also close the other gate. So we continuously just make that cycle that goes right on through. And that's why you need multiple logic gates depending on how many colors you want to use. Alright, so now that we showed you that it worked, let's go ahead and finish this connection up so you can see how you can use this for a, opening a door, or in this case we're going to set up some fireworks. So, new logic connection. Once again, we're going to do output. And we're going to connect it to this, I think you pronounce it brazier. I'm hoping I'm not saying the wrong word, but we're going to say torch. And we're going to tell it to turn on. So when the player is stepping on the switch and they see the torch light up, okay, a light bulb goes off in their head, we got the correct color. Now, like I said, this one is already done, but we need to make 2 more connections. And what we're going to do is we're going to connect it to this little guy over here. And this is a dual action trigger. And what this dual action trigger does is it accepts 2 logic connections, or 2 inputs. You can see the 2 arrows on the very top there. And then it has an arrow pointing out. That's the output. What this is this logic toy, this dual action trigger, will only fire off if it receives 2 separate inputs. So it needs an input 1 and input 2. When those 2 conditions are met, it will then activate and send out a signal to wherever we direct it. Okay, so what we're going to do is when the player gets the 2 correct colors, one from this block, one from the other block, we're going to send those input signals to that dual action trigger, and then since both conditions are met, that trigger is then going to send that signal to wherever we determine we want it to go. So what we need to do is we're going to use the logic gate, And we're going to do new logic connection, output, to the dual action trigger. I'm going to say input 1. And in this case, I use the middle color as the correct color. So we'll do new logic connection, output, to the dual action trigger. And we'll say input 2. Now from here, we're going to go new logic connection, and as you can see, the only option you get is called complete. So once the two conditions are met, everything is completed, the complete signal is going to go out. So we're going to go select that complete, and we're going to target this middle fireworks cannon we have here. And we're going to say grand finale. And I should have the rest of these set up. Oh, I don't. Okay, so new logic connection, explode. We're just going to make these other ones explode as well. So we get a nice little effect here. We're going to say new logic connection, explode. We'll go to this party cannon as well, and we'll say grand finale. Now, we need one other button and one other connection, because a dual action trigger is a one-time use creativity, for lack of a better term. So once the two conditions are met and the complete action is then set out, that's it. It will no longer function. It won't. The conditions have been met. The toy basically becomes deactivated, and it will just sit there. So once the player got the correct colors and it worked, that's it. It will no longer work. Now, if we wanted to be able to reset that, we're going to need a switch of some sort. In this case, we're just going to use this trigger. We're going to place it down, and we're going to make a logic connection. So we're going to go new logic connection. Same thing as we always do. Stepped on, player, any, to our dual action trigger, and we're going to say reset. And by doing that, that clears out the, basically, you see how you have the two arrows going in, and it looks like a box with a gear in it. Basically, we're just emptying out that box, so it can once again accept the two input signals and then go out. So we don't need to reset it now because it's already ready to go. So now what's going to happen is we're going to get the correct colors. The torches are going to light up on top, and then it's going to send that signal to that dual action trigger. From there, it's going to go to the fireworks cannon, and we're going to get a fireworks show. Now, to make things a little bit more dramatic and impressive, we're going to go use I have a switch connected to the sky changer, and we're going to use a pitch black sky so everything looks a little bit better. And we're going to turn off our wand so we get a nice little, a dramatic flare. So again, this correct color should be red. So step on it, yellow. And there we go, red. We should get the torch lit. We know that's the correct color. The signal has now gone to the dual action trigger. That's input 1. Now we're doing input 2. And there's green. See, the torch lit. We get a fireworks show in the background. Everything worked fine. Now we could have taken it a little bit further, added a time delay between the between the dual action trigger and the fireworks cannon so we could get a little bit better, a little bit longer of a pause before it goes off. Matter of fact, I'll show you how easy that is to do. We're going to reset. We reset the dual action trigger, so this should all happen again. And let's see, let's add a time delay in here. And as normal, as you guys are probably used to by now, I go the wrong direction every time. Okay, believe it or not, that's actually not intentional. Just by habit, I want to go right all the time. All right, time delayer. We'll just throw a little time delayer in between these. Put that there. And what we'll do is we'll highlight our dual action trigger. We'll delete the link to the party cannon, and instead we'll go new logic connection complete to the time delayer. We'll say start delay. We're going to adjust the properties on here. We'll put it 3 seconds. And now we'll do a new logic connection, delay complete, and now we'll go ahead and target our party cannon again, our middle one here. And we'll say grand finale. So now we could have made the logic connections from these other gates to the torch and turned it off. That way, we know we got the wrong colors. As a matter of fact, let's do that real quick so you can see how that would look. So we'll go from here, and we'll do the new logic connection, output, and we'll go to the torch, and we'll just tell it to extinguish. We'll tell it to turn off. Same thing with this middle one, since this middle one is not the correct color. New logic connection, output, and we'll turn it off. For this side, we need to do the middle, the first and last one. So we'll do this one, new logic connection, output, and to the torch, and we'll tell it to turn off. And the last one, new logic connection, output to the torch. Come on, there we go, and we'll tell it to turn off. Now we'll do this again, and we should have a little bit of delay that we can run Donald between these two blocks and see the fireworks a little bit better. Now we reset the dual action trigger. So step on this. You can see the torch extinguished. Wrong color. Wrong color again. There's our correct color. We got the torch lit. Now that's input signal went to the dual action trigger. Step on this. Wrong color. Wrong color. Correct color. Lit. And now we should get our fireworks show. There we go. And as you can see, it looks so much better when you make a pitch black sky. And that is pretty much it for the color changing blocks. Now, you can use something besides a dual action trigger. I threw the dual action trigger in here because I thought it would be, we're using two blocks, and I thought it'd be nice to also talk about and showcase the dual action trigger. You could use logic gates here instead, and you could have multiple blocks in different colors. You would have to do the same connection with a different, basically a logic gate for each color, and also then you would need a logic gate to funnel the correct signals through, and just like we did before. So, if you would just basically take the concept from our logic gates and plates video, and where we made a domino effect bounce the signal down, the input block signal down a row of logic gates, you can kind of do the same thing here, and then send the correct signals to the logic gate, from the logic gate to whatever toys you want. So you can use the same setup for opening a door. So just keep that in mind. And that is it. And again, I just used the torches for, effect because I thought it looked cool. And that pretty much covers it. I hope that was clear. It's a little bit more advanced, only because you need so many logic gates. But that, like I said, that's pretty much it. It would be nice if we could jump up and down on the actual block to change its color, because then that could be a lot of fun. But unfortunately, that's not the case. And you could actually have be a little bit evil here, and when you change one color, tell the block to change the other color of the other block to a random color, just to really mess with people's heads. But, I just wanted to give you a basic demonstration of how this works. Alright, so I think that's pretty much it. I hope this was helpful. I hope you enjoyed it. Our next tutorial, I'm not sure what it's going to be. It depends on what I get done first. I have several tutorials already set up. It's just a matter of which ones go correctly when you go to record them and which ones will go up. This is eventually all going to lead to one big finale, hopefully by the end of the year, to where I'm going to make a multiple part series where we're going to go from start to finish creating an entire toy box and then upload it to Disney. So stay tuned for that. Hopefully that works out as planned. You never know. But that's it. Until next time, take care. Bye-bye.